before we get to test time, right? Okay, so just, over a weekend, let's just kind of review here a little bit. I'm going to actually do the warm-up problems out of order. I'm going to start with the second one. I know you know this one. Rewrite the logarithmic problem into exponential form. Easy enough. Start with the base, 7 to the second, 49. Just always making sure we can convert between the forms, because I'm going to be doing some converting today too. Now, the top ones. Don't take offense to this. I copied and pasted these right out some old Algebra 1 stuff. Now, it's been a few years since you've taken Algebra 1, right? So I don't expect you to obviously have this memorized, but let's take a look because we're going to do some similar things today. Solve the following by making common bases. So my advice is you want to try to rewrite the larger number in terms of the smaller number. So I want to rewrite 27 using 3, which we can do, because 27 is 3 to the what power? Now, it's an equation. We need it all to equal out, the left side to equal the right side. If you have the same bases, now you just have to make the exponents equal. And I'm like, oh, well, yeah, I can solve that in our head, right? 9. Got it. So again, it's been a while since you've done this, so don't be like, holy cow, but this is what we're going to be practicing a little bit more of today. Now, same thing. I want to try to rewrite the bigger number using the smaller number. Now, I don't even like that 2's in a fraction, but I'm going to deal with that later. First, I'm going to rewrite 16 using 2. You're going to have a little bit of number sense. I know 16 is 2 to the 4th, yeah. And don't forget you have x up there. Now, I don't like that the left side is 1 over 2. I want it 2 to some power, even if it's a negative. There's my hand, okay? So this is really 2 to the first. So when I move it up top, it of course becomes a negative 1. Now I just set my exponents equal. Since the bases are equal, we got to make everything equal. And we're going to get a very lovely fraction, negative 1/4. So again, this is a throwback to your Algebra 1 days. It's been a while. So don't be like, holy cow, we're going to practice some more of these today. We're also going to take a look at what if you can't get the same base. I can't get 2 and 2 on each side. I can't get 3 and 3. We're going to show you how to address that too using a logarithm. All right, so exponential equations, that's what we're going to focus on today. An equation in which the variable occurs in the exponent. So basically, I'll come back to that. It's like A and B up here. You have a variable x, most of them are always x, in the exponent. That is, of course, an exponential equation. And then I just threw these on because, the weekend and stuff. Just a couple little properties to remind us of. Don't forget E and ln, of course, always cancel each other out. A and log base A cancel each other out because, of course, they are inverse properties. Exponential, logarithm, inverses cancel each other out. But you're sick of me saying it. Now, this is what we just worked on. I just showed you in those warm-up problems. If you can get the common basis, then, of course, your exponents are equal. So we're going to be doing we're going to be doing some more of that today too. Okay, as always, I like to give you a little advice, some pro tips here. So just like any time I'm going to solve an equation, we always say, even back in my Algebra 1 teaching days, isolate the term with the variable. Well, that's kind of the same thing. We want to isolate the variable expression. This time, your variable is going to be in an exponent, though. Big deal. Still the same process as you always solve an equation. Now, I'm going to try to get that common base. And of course, just like that warm-up problem I showed you, then we're going to set the exponents equal. Need a little longer blank on that one. Now, like I said, sometimes that just does not happen. You cannot get it 3 to some power and 3 to some power. You can't do it. Doesn't mean you can't solve the problem. It means you have to then switch it from exponential form to log form. So that is why we have to be able to convert between the two. Remember, the inverse of an exponential is a logarithm, if you want to write up the full word there, be my guest. And then just a little reminder, the weekend and we forget stuff. If you have a log base E, what's a log base E? ln. So make sure you use ln if you have the E in it. Log base E, we're going to use ln. and I'm going to be using the LN button on your calculator. We're going to get some decimal answers. That's why I said you have your calculators out, because I'll punch some of them in. Plus, I don't know, maybe you know what 3 to what power is 243 off the cuff. Maybe not. I hope. So, solve the following exponential equations. All right, I'm going to try to make common bases. So you might have to do, hopefully not too much, guess and check on your calculator to see 3 to what power is 243. Clearly, it's not squared. That's 81. 3 to the 4th is 81. So I would try 3 to the 5th. Man, that's so easy. I just set my exponents equal. X has to be 5. I love this common base stuff. Again, always try to rewrite the bigger number using the smaller number. So I'm going to leave my 7. I know 49, of course, is 7 squared. I don't like it's in the denominator. I want it 7 to some power. So I'm going to move it up top, which makes the exponent negative. I just set my exponents equals. Bing, bang, boom. X equals -2. We're done. I could do these all day, right? Okay. All right, same thing with the 2. First, I'm going to try to rewrite 32 as 2 to some power. You might know that one. 2 to the 5th. And then, of course, 2 to the 1st. I don't like that it's in the denominator. So when I move it up top, it makes that exponent -1, and you have the x there. So now I'm just going to set my exponents equal. I'm not going to write the 1, though. That's just for dramatic effect. And then we'll just switch this up. So some pretty basic, nothing too crazy problems to kick it off with, right? Still basic, but I threw kind of an extra number in there. You do not have the variable expression by itself, meaning you don't have 8 to the x alone. Well, big whoop, okay? 1, you can't make it 40 to the x. You're breaking order of operations. You can't multiply before you exponent. So I'm just going to get rid of the 5. Got it. All right, you might need your calculator for this. What's 325 divided by 5? 65. I did this on purpose because I'm leading you into the next set of problems. Can you write 65 as 8 to some power? It'd be nice if it was 64, right? I did it on purpose, okay? Because I'm leading you into the next round of problems. I cannot get it in a common base. So my only choice right now is to put it in a log form. Okay, well I can do that. So I would have log base 8, 65 to the left, x to the right. And I'm just going to leave it at that point right now because the next round of directions tells you to round to 3 decimal places. This, I'd have to punch in the calculator, it's gross, whatever. We have x alone, my goal, I'm just going to leave it. So, let's just remember, I'm pretty sure you remember, but just to show you again, remember in your math menu, you have to go to letter A, and that will pull that up if I wanted to type in log base 8 of 65. Just in case you needed a reminder. I know we've had some kids gone and whatnot. All right, solve the given exponential equation algebraically. Now it's telling you to round to 3 decimal places. Well, 3,000 is kind of big. I don't know if I could write 3,000 as 6 to some power, and I really don't even want to take the time to guess and check it. That seems like an inefficient use of time. So I'm just going to convert it right away because it says I can round to 3 decimals, so let's go decimal. Log base 6, 3,000 moves left, 5x right. From here, it's a calculator problem. I'm going to punch in the left-hand side, and then I'll divide it by 5. Like I said, I'm not going to punch in every single one, but I'll punch in a few here for you. So I've already got it pulled up here, so log base 6 of 3,000. And then I know to get x alone, I have to divide off the 5. I'm just going to do it all right in my calculator and round to 3 decimal places. So I'm going to put 0.894 for that one. And just because I like it x equals, I'm going to use my geometry, symmetric property, the looks on your faces, I love it when I say geometry, the symmetric property of equality and switch them. I feel like we should just do like a geometry proof someday for fun. Anybody know a little CTC action? Just teaching that. Okay, nobody? Okay, all right, just that it is. Okay, now, I don't know. I might be able to write 0.0625 as 4 to some power. I don't know. But again, we can use our calculator, so I'm not even going to waste my time. I'm just going to convert it. Log base 4, 0.0625 left, negative 2x moves to the right. All right, you guys are up. You're going to type in the left-hand side. Of course, in the old calculator, when you're done, divide it by negative 2. And this one comes out kind of decent, All right, what final answer? What do you got? Who's got it? Negative. Or, sorry, I can't read my own handwriting. What do you have for it? Positive 1. So here's the deal. Since we have 1, which is a pretty nice answer, could have we probably written 0.0625 as 4 to some power? Since we got a nice whole number answer, we probably could have made this into a fraction and made common bases. But again, says we can round to 3, so I'm not even going to waste my time trying to figure that out. Work smarter, not harder. All right, little problem on this one. I don't like that the variable expression, e to the 0.005x, is not isolated. So first thing I'm going to do is just get rid of the 100. Let's just divide that off. Make it easy. All right, 0.05x. Hopefully we don't need our calculators for this. What's 125,000 divided by 100? Okay, so 1,250. Just cancel 2 of the zeros, right? Now, clearly, I'm not going to try to make a common base of e. Let's get real. So I'm going to convert it to log form. Now, we would have log. Our base would be e. Yes, I know. I don't love that. I'm going to rewrite it in a minute. 1250 to the left, 0.005x to the right. Now, like I said earlier, and some of you might skip that last line I just wrote, which is totally fine, because I do not love log base e. You have to recognize what's log base e really on your calculator. You're going to use what button? ln. So you're going to do the ln of 1250. And then, of course, figure that out and divide off the 0.005. And this one, you get kind of a big answer for this guy. Got it. 1,426, I hear it. 0.180 if we round to 3. That is a decimal point in there. Kind of just ran in my 6 a little bit. So on a quiz, test, homework, whatever, I do not care if you put that log base e line in there or you just skip that altogether and go straight to ln. Totally fine. You know I like to be dramatic for your notes, so I put it in there. All right, so a little bit of work. I need to get, of course, the variable by itself. So I do not like the negative 14 or the 3. Can't combine them, not like terms. I'm just going to get rid of them. So I'm going to add 14 over. So that's going to put you at 25. And then, of course, I'm going to divide by 3. And I know 25 does not divide by 3. I'm just going to leave it for right now. Can you type that in your calculator and give it decimals? Sure. But, and again, I'm not going to get super picky on the rounding if you round a little differently than I do. But I always try to save and leave everything exact until the very final moment on my calculator and round it at the end. So when I convert this, you might skip this line, log base e, 25 thirds to the left, x to the right, and we all know log base c, you're probably skipping that line, you're going to do the ln of 25 thirds. So punch that in. And what fine value did you get for that? X equals 2 point. What do you got? You know what? Anybody need me to type either of those in the calculator? Just checking. Just making sure. Okay. All right. Again, nothing wild or crazy. You just have more terms on the side with the variable. So we need to get rid of the 6. We need to get rid of the 15. All sorts of good stuff. You cannot times 6 and 8 together. You can't multiply before exponent. Now, every year, I have some kids that want to divide off the 6 first. I'm like, well, that's fine. I don't care. Just make sure you do the 15 by 6. like, God, that seems like a lot of fractions. I don't know if I have that in me. I'm going to get rid of the 15. Let's just subtract it over. Okay, so 2,601 minus 15. Punch that in your calculator. What do you have for that? 2,000. Don't all yell it at once. What do you have, Brooklyn? Agreed. And then I'm going to divide off the 6. Because I cannot multiply 6 and 8 because of that exponent on there. Okay, so type that in. 2,586 divided by 6. That comes out pretty nice. 431. Clearly, I'm not going to waste any time standing here and be like, oh, can I write 431 as 8 to something? I'm using my calculator. Let's go log. Log base 8. 431 moves left. Negative 2 minus x moves right. Now, really from here, you can just go straight to your calculator pretty much to finish this guy off. You know how to type this in your math menu, letter A, blah, blah, blah. Add the 2 to that. And see where we're at here. So punch in that left-hand side. You should get about 4.917 for that. Final answer, do you mean to type this one in? Final answer, though, I've got the negative on the x. I'm just going to switch the signs. I'm not going to rewrite it. I'm just going to switch them. Okay. Do you need me to type this one in, Courtney? I will. You just had a look on your face.
Oh, no.
Okay, all right.
I didn't realize it was negative.
You just had a look on your face. I just want to make sure. Okay. All right, just checking. So any questions on E? All right, then you know I like to throw some, hey, let's look at some kind of fun, interesting little cases at the end to you. Just when you least expect it. Which one of our favorite F words in math is going to slap us in the face here? Factoring. Your F word math we won't talk about. Okay, we're going to factor it. Don't let the E part wig you out or scare you. Now, let's do the numbers. So multiply to negative 6, add to negative 1 in the middle. Nobody messes that up. So I'm just going to fill in the numbers. Now, when we factor, we're used to x and x, but we have e to the 2x. So that means you have e to the x and e to the x. Now, ignore this next line I'm going to write, because I just want to prove to you if you FOIL it out, you get it back. You don't have to check it. I'm going to do the check for you. If you FOIL these together, when you multiply exponent expressions, you add them when you have the same basis. 1x plus 1x, 2x. Then I'm going to have minus 2e to the x, or sorry, plus, minus 3e to the x, and then minus 6. And of course that combines to the minus e to the x in the middle. So just proving to you that if you FOIL it out, it does work. Like I said, you don't have to do that. All right, now, 2 for the price of 1. We're going to, as always, set each factor to 0 and solve them. So we're going to get 2 answers for this one, just like we do every quadratic, every squared. Add 3 over, subtract 2. And of course, I can't figure out e to what power is 3, get real about it. So we're going to convert it into exponential form. You're probably going to skip this line, log base e. I know you know what that is. 3 to the left, x to the right. And of course, when you type that in your calculator, you're doing ln. All right, ln of 3, punch that in. What do you got for ln of 3? 1 point. What'd you round to? 0.99, I like it. I'm already worried about this second one. I saw the negative 2 and I was like, oh gosh, I don't know. Because when I convert it to log form, I know that's ln, I know. Negative 2, can you do any form of a log of a negative number? No, so we're not going to get an answer out of this one. Now, I'm not going to write no solution, because I do have a solution. I'm just not going to get a solution out of this equation, because of the negative. So done. I'm done with it. Questions on that? I'll throw a couple tricksters at the end. Okay. All right. Again, favorite F-worded math, factoring. I'm looking at that left side and I'm like, oh wow, there's a lot of good stuff in that. But I see some commonality to it. So I'm like, okay, all right, I can factor, I can do it. I see we have an x and x squared. So I can take an x out. I also see, just for, color coding here, variety of life, they each have e to the x. So my greatest common factor, I'm going to take an x and an e to the x out. Now, to get back, to distribute through to get this back, I'm going to need the 3. And what do you need for the last term? Another x. So that's going to be easy to solve. Just like always, we set all our factors to 0. We're going to solve. Second one, of course, super easy. You're going to get -3. That's, nobody messes that up. Let's back up and talk about the first one. Okay. Honestly, I can do a little mental math on this one because I'm like, well, you're multiplying and you got to get to 0. X has to be 0. 0 times anything. 0. And even if you're like, well, how come I'm not addressing the x, so many x's, the x and the exponent? One, I really don't care about it, because if this is 0, the whole thing's 0. Or even if you do think about 0 in both of them. I mean, you have 0 times 1, still 0. Okay, done with my 0 spiel. All right, final problem of the day, and this is a good one. Now, I cannot get the same bases. I can't get 6 and 5 into the same base, okay? You can't multiply by something, because you'd have to do the exponent first. So this is going to be a fun one here, because I'm like, oh, I'll put it in log form. Piece of cake, got it. I'm like, you have 2 variables in the exponent. That's a problem. So I'm going to get fancy. Now, I can do anything I want to any equation, as long as I do the same thing on both sides. So I'm going to put a log on each side. And we'll get into the y. Now, I could have done ln. I could have got fancy and log base 7. Who cares, as long as it's the same thing. Really, I'm in a log base what? 10, which I can use the log button on my calculator. I mean, I could do log base 3 on my calculator too, but I'm trying to keep it easy on myself, right? Now, what's the purpose behind it? Here's where these properties come into play. I'm going to now use my power property, where you can drop the exponents in front of the logs. So I'm going to rewrite this as x times log of 6. I'm going to rewrite this one, I'm going to drop it in the front, x minus 2 times log of 5. All right. Now, choices. I got choices here. I could distribute log of 5 through. Yeah, I could do it. It's really not going to get rid of anything for me though. Remember, log of 6 is just some gross decimal, so is log of 5. Decimals. We got a lot of decimals in here. So I'm going to work smarter, not harder. Instead of distributing, because that doesn't cancel anything, I'm just going to get rid of log of 5 and divide it off. Hasta la vista, log of 5. Okay, so let's pull up the calculator, and I'm going to type in log of 6. So I'm just going to, you could have done ln, doesn't matter. I'm going to do log of 6 divided by log of 5. So I'm going to round that. That's about 1.113, let's say. And I know we usually I'm going to switch the order. We usually like the x behind the number, the coefficient in the front. So I'm going to put this 1.113x. I'm like, oh, algebra 1, easy. I mean, the x is on the same side. For dramatic emphasis, don't forget that's a 1 there. I don't need the calculator for that, I got it. And of course, I'm just going to divide it out. And of course, I don't remember the answer, so I'm going to cheat and look at my sheet here. You end up with negative what? Type it in. negative 17.69970 whatever. Got it. So, just FYI, remember, I choose to put the log on either side. You could have done ln, you could have done log base 7, log base 7. It doesn't matter. You need some form of a log on either side. I just do plain old boring log because it's easy to hit the log button on my calculator. That's the reason behind it. You can pick any log that you want, my friends. Okay, so a couple things. Yeah. I love your reactions. So Thursday for Funzo. Come on now, come on. We're going to have one of those little, teeny, tiny, short, sweet, little no graphing calculator quizzes, okay? There are 4 total problems on it. There's 3 very simple, simplifying problems, like, I don't know, I'm just going to make some log base 2 of 4. Just so you can visually see it. How do you simplify that without a calculator? You make this what? 2 squared, final answer. So there's 3 little simple sort of simplifying problems like that you don't need your calculator for. And there's one, you know I love a graph without a calculator. There's one graph on there of a logarithmic function where you're going to have to put it in exponential and do the t-chart by hand. And for fun, because I know you love it even more, I am going to let you do it in partners. But they're different. I have 4 different versions of it. Oh, God.
Don't do this.
Yes. Okay. And just FYI, obviously, I love it. Your chapter test, I know, Monday test kind of stinks. It is what it is. It is what it is. But we're getting down to the number of days in the semester, my friend.